Day 22, it's Thursday. Cyber Defense Tuesdays. CDT. We make a new acronym. Cyber Defense Tuesdays. MH216 at 12:30. Today we worked on some addressing, terms and concerns, some of this information right here. Made sure their wireless connections were working, and then one of my favorite things we talked about, security. Okay. And I didn't get one of the board sections copied, but I'll write it through here in the whiteboard review. Here we go. We should know, not necessarily experts at configuring it at all yet, but we should know what DHCP is, network address translation, and domain name services. Dynamic host control protocol. So, automatically get an address, convert addresses from one network to another. For example, for going out to the internet, you go a private address internally to using a public out on the internet. Okay. Don't use anymore. These are security protocols. Everything that you're doing in wireless should be WPA2. We're not even going to go through the previous ones. These two, I believe, I'd have to look it up. Maybe the same algorithm in behind them. Anyway, neither one of those. You know, in fact, let me double check this. No. Okay. Wi-Fi, radio frequencies. Talk about these waves can go. You know, they can go through things. Not everything, but they go through things in the air and so forth. And we have these two frequencies that we use in Wi-Fi. Okay. Go further, typically not as much data transfer or bandwidth. Let's just say it that way. Better just say it that way. Bandwidth. This one, larger bandwidth, shorter distance. And then they have these categories. You know, a long time ago, one of the first ones were A and B, and then they went to G, and then they went to N, and now AC. So you see a lot of N and AC out there. And then also another wireless technology is this 4G, 5G, long-term evolution, I believe. But anyway, that one kind of fits in between. This is really not fulfilling all the standards of 4G. So you heard those advertised. And then the goal is, where are we going with 5G? And that'll be worth a topic someday to investigate. Alright, so we also verified, when you're thinking about, we looked at, you can measure the band width, right, of your connection. So the PCs are 1 gig. If they're connected to a 1 gig port, yeah, then your bandwidth's 1 gig, but your throughput, would be less because of a variety of things. It could be more than one thing, but one of them could be latency, the time it takes for the devices to move the information through. So let's just look at this here. So a PC, for example, when it sends information to the switch remembers the MAC address, and if it's, let's say, eventually heading out to the internet, the switch is connected to a routing device in here. That'll look at the IP address. If the IP address isn't on a network, one of these local networks, we have all these networks connected here. 1, 2, 3, 4. If it can't, then it'll default out to another device. And if it can't find it, let's say there's another network there, then it'll have a default that in our case here, they eventually end up in the NIAC IT, which then eventually ends up on the internet. Okay, so let's go back to some of the other items. So we have a multi-layered switch. We talked about why it's called multi-layered, because it works at the data link layer, the network layer, and even a little bit at the transport layer. You'll learn later on in the OSI model. Okay. We also talked about down the road here we'll connect an access point. To their networks. Now, we didn't do a whole lot of work with it. Let me use another color here. But off of the switch here, we did connect your wireless routers. Okay, the 4 groups wireless routers off of there. Now remember, that's different than what we're going to be doing here. Okay, those were, our scenario was maybe we have some people living upstairs and we're going to give them internet access off of our equipment. Okay, maybe free, you know, that's just part of the apartments above our small business. Now, okay, so we separate that. One thing I will mention though, let me use, I don't know what color I use. Yeah, I can use this. Those wireless routers, they're really kind of like all of this here if we were to combine it into one device. That's what they are. They can route, they can switch, and they have a radio in there for wireless frequencies to read them, so forth. So they're kind of all those devices in one. Got a couple. So we create this scenario where we have we need 5 networks, 5 separate networks, you know, so these are on separate networks, and we're going to route between them. Okay, so we'll use a routing device, and let's say that has 5 networks connected to it. And then each of those networks, we want 6 workstations, and these are minimum. The bottom, the minimum. So, you know, we might want to grow from there. And in our scenario, we have this address. I made it up. Okay, nothing in particular except it's a private address, but I made it up. And it's a /24. So somebody gave us this address, which then, looking at it, this /24 says we can't change that. Okay, they're saying, okay, you have this network address, and so somewhere is out here somebody's going to point to our network. They're going to say, if it's this number, send it to this router. Now this router, okay, I'm over here now, this router needs to send it to up to 5 networks and maybe more. Okay, so what we have to do is a term called subnetting. So we only have these bits to work with. So that's what I've drawn here. I've drawn the 8 bits that we can do with them whatever we want. So the concept is they'll use the term, we're going to borrow bits. So we're going to take this line here, this is the network part, and this is the host or interface part. Right now, we could put 254 different hosts on there. But that isn't what we want to do. What we want are these smaller networks. I'm up here in this picture. What we want are these smaller networks with, you know, a few workstations on each one. Okay, whatever your business is. You only got 2 or 3 people at each of the locations. Whatever. Okay. So we're going to take this address and split it up. So what we want to do is we want to find a line in this address here where we're going to split this and make the network a little bigger and the host a little smaller. So we're going to make less hosts, not 254, but over here we only have one network, but we want at least 5. Okay, so here we go. We're not going to actually calculate it out. So what we did is we said we got to figure out where we're going to draw the line. So I figured out we drew the line here. And let me explain briefly how we do that. So if we look here, if we borrow over to here, now we have 3 more bits that can be network bits. 3 more bits can be network bits. So if we start putting our combinations in there, and what we did is we looked, says if we borrow 1 bit right here, if we borrow 1 bit, we would only add 2 networks. If we borrow 2 bits, now we have a combination of 4 bits, so we can add 4 networks. If we add 3 bits, 2 to the third is 8, so now we have 8 networks. So we want 5, but we can go up to 8 by moving this part. Now this will be the network part, and to follow my analogy, this is going to be our host or workstation parts. That leaves us 5 bits, 32 combinations, but we can't use 0 and we can't use all ones. 0 is the network, all ones is the broadcast. So we can have 30 addresses, well within our 6 networks. Okay, so we have plenty extra here, and we have some extra here. That's called subnetting. More on that next week. Let's keep. So last thing here we want to cover is this idea of data and how we look at data in terms of security. More about how we look at data. Let's talk about what could happen. Data is our asset. You have all kinds of things that are assets in a company that you would not want destroyed, like the building burning down or something. But we're just talking about data, and we're talking about data that's digitized here primarily using computers, not on paper right now. So first thing, is there a threat to the data? Could something happen to the data? A good example, do you live near a river and your place get flooded? Do you could be a tornado? Depending where you live, could be a hurricane. Okay, could be an earthquake. Could be a fire if you're in California, etc., etc. So all kinds of threats. So now the threats we're thinking about are ones that probably deal with people getting at your data or doing something to your data. So is there an agent that can carry out the threat? Is there something that can carry out a threat to do something to your data? Steal the data, change the data, okay? Lock up the data, ransomware. Is there somebody who can do that? Then, are you vulnerable? I mean, is there a reason somebody will do this? Okay, I mean, would they do ransomware on somebody's data who don't have any money? You know, or a nonprofit which doesn't have any extra funds, you know, if money is what they're after. So, and are you vulnerable? Could it actually happen? Okay, are you vulnerable to this? And in some cases, your vulnerability could be pretty high. And then once you know that, now you look at, this is crucial in businesses, you look at the risk. Okay, you decide, you know, how much would it cost us if this happens? How much does it cost us to try to avoid it? Okay, so the risk part's really important because you can't protect everything 100%. So it's like this gauge, you know, it's moving up and down. You know, like if something happened to the data, would you lose a lot of money? Okay, for various reasons, or would it? This could be worse than money, losing money, ruin the reputation of your company, lose all your customers. So you look at the risk and try to figure out now how bad is it. One thing you do, you can remove the risk. For ransomware, we talked about that. People are buying insurance. It's probably not helping lower the ransomware, but they're so worried about it. They don't think they can mitigate it, like do something to stop this from the risk, to stop this from happening, your vulnerability. You can try to mitigate it. Okay, more passwords, more locks, more everything, encryption, all this stuff we can do. Or you can remove the risk and get insurance. Like some people don't want to risk managing the information, so they move it to the cloud and they let the cloud secure it and back it up and do all that stuff. And then, of course, they pay them to do that. Okay? So to narrow it down, you have to decide how big is the risk, how big is the risk, what would it do if something happened. And then you can either remove the risk, insurance, send the information to the cloud, try to mitigate it, put in a bunch of actions to stop it, okay, or you can just accept it. That's probably not going to happen. Okay. Yeah, some people do that one. So we have to worry about, what do we have to worry about for data? Data integrity. If I said that right. So we have to be concerned if the data is accurate. Okay? Then are the people that we want to see the data seeing it? Confidentiality. Okay? Data, and then make sure it doesn't change, or it's accurate, who sees what, and then we have to make sure the data is available. Whoops, let me back up here. To who needs it, availability. So, yeah, this is a good way to look at, really. Now the data, what states is it in? Well, the data could be stored or at rest. Ransomware, that's usually where they get it. Could be moving, in transit, through networks, or it can be being processed. And then the last thing I'm going to mention, what do we do to help protect the data? Well, I'll put those in another color here. Now I'll just give them. We have products and devices. Oops. Products and devices. We have firewalls, virus softwares, we have ways to authenticate people, we have all these products are going to try to keep our data, for these particular things up here. We have to work with the people. We have, in fact, let me back up. We're going to cover people more later on. How you like that? See that disappear? Okay. Whoa! A few more lines disappeared than I wanted to. Okay, so we have products and devices. We have procedures. Rules on how to do, not rules, but how to do things to keep our data secure. And then those rules follow our policies and guidelines. Alright, so if I was going to highlight this, you can get all kinds of products, devices, firewalls, and so forth. You can show people how. You can have procedures, like what happens if there's a breach, and all these procedures, these steps we can go through. And then you have policies. What can people and people not do, and guidelines for in a business. Okay? The key element in all of this really falls under the term, another P, people. And we'll talk more about that later. Now that's it. Sorry, that's got to be the longest whiteboard of the year. That's it for today.